the exciting potential of 3D printing in the realm of foam concrete is explored, offering insights into its application for accelerated construction. The innovative methods by which this technology could revolutionize building processes are highlighted. What if you could build an entire house in days, not months? Imagine a world where sustainable, affordable housing isn't a dream, but a reality, thanks to our revolutionary new material and an incredible technology. Get ready to discover how 3D printing foam concrete is about to change construction forever, accelerating development like never before. Unlike traditional concrete, foam concrete is a smart material that breathes. Its secret lies in the millions of airtight bubbles inside. These bubbles not only reduce the weight to 1/3 of ordinary concrete, but also form a natural heat insulation layer. Measured data showed that the thermal insulation effect of a 20 centimeter thick foam concrete wall is equivalent to that of a 1-2 meter thick solid clay brick wall, which can directly reduce building energy consumption by 40%. Even better, its density can be controlled as precisely as the strength of coffee from lightest wood at 200 kilograms, 1002 rock solid at 1800 kilograms per cubic meter, from 200 kilograms per cubic meter light as wood, to 1800 kilograms per cubic meter solid as earth. A single material can satisfy the needs of everything from structural load-bearing walls to decorative elements. On a remote Norwegian island, this feature enabled the construction team to make dozens of shipments of building materials in a small boat. This working 3D printer is growing walls at a rate of 0.5 meters per hour. It requires no scaffolding, no formwork, and no workers operating brick by brick. The print head acts like a pro-size cream framer, stacking layers of specially formulated foam concrete with no more than 1 millimeter of error in the thickness of each layer. In a demonstration project in Dubai, the process has resulted in a 70% reduction in construction time and an 80% reduction in labor costs, while keeping material waste to a staggering 3% or less. Conventional construction typically wastes as much as 25%. Even more disruptive is the fact that architects are now free to design complex shapes such as curved walls and openwork carvings. As this designer says, "We have finally broken free of formwork and made the leap from making buildings to writing buildings. We have realized the leap from making architecture to writing architecture." When an earthquake struck Italy, 3D printed emergency housing provided shelters with insulation for victims within 36 hours. In Rwanda, Africa, mobile printing equipment is building village clinics at a rate of 10 per week using local laterite mixed with foam concrete. But perhaps the most exciting application comes from beyond Earth. The winning team in NASA's 3D printed Habitat Challenge designed a moon base, printed from lunar soil mixed with foam concrete. The material is not only radiation-proof and resistant to temperature differences, but it also self-cures in a vacuum. The same principle is being used to design an integrated printing solution for offshore wind bases, solving the problem of marine corrosion in traditional construction. The next time you pass by a construction site, imagine a scene like this. No cacophonous construction noise, just the gentle hum of the printer. No dust flying, just materials precisely in place. From disaster relief tents to moon bases, from customized homes to infrastructure, 3D printed foam concrete is opening the door to a more efficient, environmentally friendly, and imaginative world of construction. If you're wondering if a building is 3D printed, there's no an easy way to tell. Look for those horizontally layered textures like the annual rings of a tree. Share any 3D printed buildings you've seen in the comments section. And don't forget to like and subscribe too.